Save systems can be annoying. We struggled at first to make a system that made accessing data easy, was efficient to load, modular for multiple files, type safe, and still human readable. After a lot of trial and error, from JSON parsing nightmares to bloated auto-loads, we've landed on something we actually love. Not only is it stupidly simple to use, it's fast, supports multiple save slots, and lets us add custom logic specific to each save type. Plus, it's statically typed, unlike JSON, so you know exactly what you're working with. So before diving into implementation, let's just see it in action first. Using our abstract save class, we can just extend it in a new file. Say I'm making a burger tycoon game and I want to save my ingredients. Buns, patties, cheese, sauce, as well as which toppings I've unlocked. Let's call this burger save. We extend save, copy in our static load function, I'll explain this in a second, and export our fields. Ints for the counts, a float for burger sauce in milliliters, and a dictionary mapping topping names to whether or not they've been unlocked. Done. That's the whole save file. Now we can load it from anywhere in just one line, burgersave.load. Then to edit our values, we can set patties to 12 and mark pickles to be unlocked. When we're done manipulating data, simply do bs.save. One line to read data, you can edit it as if it were a simple struct, and one line to write the data back to the file system. If we check our user data folder, there it is. But notice how buns and cheese aren't in there? That's because they're still the default value. They waste zero storage if they haven't been changed. This can be hugely helpful for games with lots of save data. I'd also recommend using packed arrays if storage or memory is a concern of yours. Again, since it's a Godot resource file, you can use any GD script type as you please. Okay, so we got our data. Now let's add a helper that calculates how many burgers we can actually make. Each burger needs 2 buns, 1 patty, 1 cheese, and 25 milliliters of sauce, so we just return whichever ingredient is the bottleneck. We load our burger save the same way, call getMaxBurgers, and it just works. 12 patties but only 4 buns? You're making 2 burgers. By coupling our helpers with the data that they are specific to, everything stays nice, simple, separate, and modular. Okay, now let's get into what's actually happening here. Our save files are Godot resource files, .tres, not JSON. Resource files use Godot's native typing, which means you get autocomplete, catch type errors at write time, and everything just looks as expected. JSON, on the other hand, makes you parse every single field. You're constantly casting, checking for nulls, and praying your keys are spelled right. To make this work, we have a base abstract save class marked with @abstract, a relatively new Godot feature which handles all the loading and saving logic. Each specific save just extends the space and defines its own fields. Want a new save file? Extend save, add your exports, copy the one-liner load wrapper, and that's it. This also means that you can easily add common properties to all saves, like last write for tracking when files were modified. Our base save class is also only about 100 lines of code, and it can be found all in our Discord in the link below. So what's this part about? The static load wrapper here is the secret sauce. Instead of needing some auto load to fetch your saves, you just call burgersave.load or configsave.load, whatever, from anywhere using just the class name. Because in Godot, these namespaces are always exposed. Under the hood, it checks if the file exists, loads it if so, or returns a fresh instance with default values if not, so you never need to explicitly generate data files. We also support save slots. Some saves should just be per slot, like level completion, while others should be global, like your volume settings. You just pass a boolean when defining your load function. Slotted saves go in directories like slot A, slot B, etc., and global saves sit at the root. If you're deleting a slot, just nuke that folder. For us, an auto-loaded game state singleton tracks the currently selected slot, but you can store this however you like. So what are the downsides? Now, resource files can contain functions, which is amazing for utility helpers, but this means a malicious save file from the internet could run arbitrary code. For a single-player game like ours, this really isn't a concern. And since our files are unencrypted and human readable, you can just open them and verify nothing sketchy is going on. Speaking of which, we don't encrypt, but you can still totally do it for resource files, dealer's choice. Just know that encryption adds load time, and for dev builds, you'll probably want to skip it anyway so you can manually tweak values. However, since each save file can be made small, modular, and single purpose, encrypting and decrypting a single save honestly wouldn't be bad at all using this implementation. What makes this approach so great? We split our save data across multiple files, config tres, completion tres, world tres, etc., instead of one massive blob. This means loading your volume settings doesn't require parsing your entire world state. Faster loads, cleaner organization. Now the real power of resource files is embedding logic directly into your saves. Our game's completion save, for example, has an isBeat function that checks if a level is complete. It also auto-updates the completion percentage whenever you mark a level done. Our achievement save can trigger Steam API calls right from its unlock function. You could never do this cleanly with JSON. For development, we also made a special dev slot that loads whenever you run a scene directly without selecting a save. No more corrupting your real progress while testing. We also built a debug menu that lets us flip values in the dev save at runtime, super handy for testing specific game states without manually editing files. And since everything's unencrypted, we can just open the TRES files and change things directly if needed. So there you have it, a save system that is simple to extend, fast to load, type safe, and actually pleasant to work with. Again, the full code is in the Discord linked below. If you want help with your own system, or you want to follow STUB's development and become a tester, you can join the server for all of that as well. Thanks for watching.